system, and I'm not going to talk about how it's used. But just to show you this one slide. In a typical motion capture, professional motion capture system, you put markers on the body of a character, and there are cameras, so there are still cameras, but those cameras are not like a typical camera. They are infrared cameras. So their job is basically to track those markers. So instead of getting a video, you get a series of data which are X, Y, Z location of the markers. Once you have the location of the markers, you can apply the same movement to a computer character. So that, or use that data for any other purpose. In a typical computer animation situation, we use motion capture system to animate a character. There is absolutely no reason to limit a motion capture system or similar technology to computer animation. Once you have those movements, you can apply those movements to any other algorithm and use them for any other thing. For example, to play a game, or even consider your movement as an input to a typical operating system interface. So by your body movement, you are telling your computer what to do. So again, the infrared camera based, or sometimes called optical motion capture, are just one example. There are other examples, for example, the inertial or magnetic type of motion capture. And in general, basically a category that sometimes in HCI is called wearable sensors. What does that mean? These are basically different type of sensors that you can put on your body to detect not only just motion, but also other features, other data about the person. For example, you can have accelerators put on your body, which we have a project here at Carleton. We're doing that, and detect the motion. Remote that you guys are familiar with is kind of doing that. So you have a sensor that is detecting the motion and sending that information wirelessly to your computer, telling how that point is moving. Imagine that you can have these sensors all around the body and capture the motion of the full body. Or you can have other type of sensors to collect non-motion information and use them for other things. For example, I was in a conference last summer, and there were sensors on the chest to detect breathing, and then based on that, they were basically providing some information to the computer. So you basically, by breathing in and out, you are providing input to the system. You can imagine how it can be useful, for example, for many people who are completely disabled, and only by breathing in and out provide input to the system. And also, as I said, speech recognition is another thing. Speech recognition has been around for ages for voice command, data entry, or even animation. And there are different technologies, and I'm not going to talk about them. You see more and more use of them. And as I said, they've been around for ages. They're still not as reliable as we want them to be. And the second part of this whole talk was talking about like output technologies that usually start with graphical displays. Graphic displays are the most common type of output devices. The most common type of graphic displays themselves are the 2D displays that we are familiar with. We also have 3D displays, which themselves can be 3D on 2D, which is, for example, the environment that you're looking at. So when you go to your operating system, you're dealing with a 2D interface. It's a 2D word on a 2D screen. When you're in WebAlive or playing some other game, you're dealing with a 3D interface, but still on a 2D device. And finally, you can actually have 3D displays. So these are three different types of displays that you can theoretically have. I'm not going to talk about all of the details of 2D displays, as hopefully most of you are familiar. 2D displays are either raster or vector graphics, which basically goes back to the concept of scalability of your images. Some of the most common things that you need to know about graphic displays are the number of colors and aspect ratio and resolution. So how many pixels you have, how many colors per pixel you have, and what's the arrangement of these pixels. Again, I don't want to get into detail of it. Here are some of the standards that we have out there, from simple NTSC TVs, old TV standards, all the way to HD TV and high resolution systems. And again, I'm not going to talk about widescreen displays and some issues related to aspect ratio that if you have watched HD TVs, you are already familiar with when you watch, for example, a full screen image on HD on widescreen or the other way around, and the problems that happen. I don't want to get into detail of these things. And obviously you have 3D words, still watching them on a 2D screen. There are a whole bunch of different tools that you guys are all familiar with for creating 3D words, from markup languages which are web-based all the way to different toolkits that we use to create 3D environments. For example, game engines like web.alive tool that we are using right now, and many other tools. And finally, we have real 3D displays, which are basically a huge talk on their own, from simple stereoscopic, which are the most common ways these days that we use glass print for our left eye and the right eye, and that's how we detect